Hello, everybody.
Hi, everyone.
We are back after another 10-day break.
Yeah, 2-week break. Um, we promise we'll get more consistent eventually.
I've just double checked. We are coming through the audio and the stream. Let us know if one of us is louder than the other. Still figuring out how to internet. Basically, when you're
Pretty much.
when you're as Neolithic as us. I mean, we're both. I think we're both turning a particular age this year, aren't we? That makes us old.
Just
So ancient, crusty.
Can't use technology anymore. Gee, you just lose it.
When you're born in the 80s, man, it's all about floppy disks and 486s. I mean, I know people older than us talk about Amigas and stuff like that, but we're from the floppy disk age.
Well, I was talking about how I have been a Power Builder developer, so...
Yes, that is an ancient technology, my friend. You are wise beyond your years, you mighty sage. Well, where have we been? Jake was on holiday.
I was on holiday.
And I could have streamed. I just didn't want to stream by myself because, I don't want to be like that guy trying to keep everyone G'd up while I'm also trying to, think. It's just, I can't do more than half a thing at a time.
It wouldn't be those guys then. It would just be that guy.
Apparently, I'm a bit louder than you, Jacob.
All right, hang on. Let's see if we can do something about that.
Yeah, get your volume up, boy. So this is what you wanted to tune into, right? Two guys adjusting their volume levels. This is what we don't do hacking anymore. I've just decided all we do is adjust volume levels. That's what the stream is about now.
Is it automatic? Do I have to push anything to make it adjust?
Oh man, you really do sound like you're a Luddite. Two guys, one
box.
Oh boy. There should be levels, or just have it close to... Maybe what I'll do...
No. So I changed the volume slider thing for you, but I don't know if I have to... There's no apply button or anything.
Yeah,
so
that should be fine. That'll do. Right, yeah. As we were saying earlier, what you've tuned into is us just getting our audio levels perfect, because that's how much we care. What's a holiday? I don't know. You'll have to ask someone else.
Yeah, it has been a long time since I've had a holiday.
Yeah, except you were the one who went on one to an island full of bushfires.
Typical Australian holiday.
Has there been... Normally we do try and do a little bit of news, but guess what? I didn't bother to look for anything.
I have not had a chance. It's my first day back, and so I'm going to claim that as my excuse.
Yeah, and I'm going to claim general laziness, so I haven't looked either. So
nice.
Let's assume bad stuff's happened, and I mean, I know I've looked at stuff and been like, intriguing. I suppose those crypto busting laws, Labor has said, maybe they are open to a little bit of abuse. So that's interesting. Other than that, let's get into it, Jacob.
All right, let's get into it.
What box this week is have we got to have some fun with?
Today we're dabbing.
Oh yeah, dabbing. Did you give the stream an amusing name?
Yeah.
Sweet. What was it? I
said, is dabbing still cool?
Dabbing is... It's not cool, but that's fine as a name. It's ironic. Mork Walker, who's in the comments, he probably just dabbed in his seat at home, because dabbing is... I don't know. I feel like I've just accused you of a major crime by saying you dab. I don't know if you do or not. Anyway. So this is, again, a retired Hack the Box box.
It is. It got retired 2 weeks ago.
Stream we did, which I'm rendering out in that video editor we got in that Humble Bundle for cheap, was... We didn't have a useful box to do, so I just went through how you would automate stuff in a CTF. So that'll be on YouTube. So it can't still be cool if it was never cool. Yeah, that's a good point. It's like me. It was
cool to someone.
Anyway, so that'll be on YouTube shortly, so you get to listen to me stumble through stuff. But so another Hack the Box CTF retired.
Yep.
This one had some interesting bits in it, so let's get started.
Yep, let's get started. We run an mmap scan, like we normally do. I've forgotten how to talk. Uh, we get 21 for FTP, 22 for SSH, 80 for HTTP, and 8080 for HTTP. So that's the wrong window. Let's open this window because I'm so prepared.
So just to run through, an Nmap scan is Nmap is a handy utility for seeing what stuff's listening on a server,
Yeah.
or an IP address or a domain name, whatever it is. It's whatever it finds listening.
10.10.10.86. Where'd that come from? 10.10.10.86, and we get a login screen. That's no fun.
Oh yeah.
Let's look at 8080 in case it's got anything more interesting we can look at. And we get an access denied, so that's not very fun. We had FTP, so let's try connecting to FTP. Lucky it's not the last thing I did with FTP. Anonymous, and we don't need a password for anonymous. We can log in.
So something to note here, FTP servers, depending on what one you're running and how you've configured it, sometimes will always allow a user called anonymous in.
Yes.
It's the same as like computers with guest accounts. That can be a problem depending on what that anonymous account can see.
Yes, and our Nmap scan actually tells us as well that we have anonymous login allowed with read-write, read-read access to a file called dab.jpg. So we really didn't even need to... I mean, we want to connect to download this file, but if we wanted to, we could see everything we needed to straight from our Nmap results. If it said no anonymous login allowed or something like that, then we'd know that we need some creds before we can attack that port. So we do a dir, and we can see, like Nmap just told us, there's only one file called dab.jpg. Let's get that.
Yep. Get that file.
Get that file. Let it download. Do a little dab because we successfully downloaded a file.
Yep. Every time, here's my challenge to you, the fair listener.
The viewer.
Every time we say dab.
Every time we achieve something cool, we have to celebrate with a dab.
Yeah.
And
yeah.
we're just going to trust that you did it.
Yeah, I just did one, man. I don't feel any cooler. I feel like less of a human being.
And no, this is not the time to bring up that we should have webcams so that we can prove that we are also dabbing.
Yeah, no. You don't need to see my face.
No.
It's too beautiful.
Yeah, so we've got this file. If we... Can I open it straight from the command line? I don't know how, so I'm going to be a noob and use the GUI.
There is like something I had a while back that let you view images in the terminal, but...
Just ignore all of those other boxes that are probably active and we're not going to do anything with.
Don't worry, when we edit it, we'll for YouTube we'll censor some stuff. Would you look at that? There's a guy dabbing.
That is a pretty cool dab. So there's nothing useful there looking at the picture, but because it's an image, steganography is a common thing in capture the flaggy stuff. So we're going to use a tool called steghide. We don't want to run it against that.
So while Jake's doing that, so steganography is the art of a similar kind of family as encryption. You take an image, and in that image you hide a message. So that might be altering the values of pixels by a few a brightness level, so that when you up the contrast or brightness, you can see the text. I think steghide uses like some sort of binary format to hide data. In this case, a file called dab.txt. But this one's encrypted as well. If you ever want to send something to someone that's secret, you can use tools like this to hide it in an image. It goes back a long time, so like hiding messages in text. One of the early versions of it was like you'd write a note to someone, and then you'd both have a particular overlay for that with certain holes in it, and you'd choose what letters would fall under that hole to send another message inside your message. I probably didn't do a great job of explaining that, but just wiki for steganography.
Yep.
Um,
Okay, so There is no passphrase, so when that asked me for a passphrase running the extract, I just hit enter, so it was completely blank.
Yeah, and there was nothing there.
And in the file, it just says nope, so we got nothing.
There is another box though, where that came up.
Yes.
So
there's also plenty of challenges in the Hack the Box challenges, which we can't write up, but there's a few good steg challenges that are fun if you want to dip your toes in how all that stuff works.
Yeah, and it's probably one of the more accessible ends of, I suppose, CTFs and information security is stuff like this, like because you generally don't need to have a deep technical understanding of how stuff works in memory, but you can kind of get the gist of what you need to do from Wikipedia or Googling around for stuff. So, plus you can do it yourself with a pen and paper if you really want to.
Yeah. Okay, so we got nothing from the FTP, so we'll start at our first website that we can actually interact with, and which is this login form on port 80. We're intercepting our login requests so that we can steal it and bring it over to, let's call that login.request. That'll do. I can just paste straight in, can't I?
Yeah.
I need to press I to go into insert mode, and for some reason burp adds extra line breaks.
Yeah.
So we're just going to kill all of those. There's probably a shortcut to do that, but I don't know what it is.
So you thought you were watching a stream about doing a CTF. Really, you're watching a stream about using VI. You forgot the M on Vim, mate.
What's the difference?
For what you're doing, almost none.
From what I just did, everything was exactly the same.
VI is probably just alias to Vim anyway. I don't know. That's a bold claim. That might not be true. Anyway, onwards.
Actually,
I made him lose his train of thought.
I lost my train of thought. So, I don't think I actually wanted to do that because I generally only save these when I want to run SQL map, which is what we did the first time around, but it's got nothing to do with, it doesn't actually get you anywhere, so we're not going to do that. Just ignore that step. We don't need to save the request. What we're actually going to do is run wfuzz. Instead of doing Hydra, which would probably work in the exact same way, I'm going to use wfuzz because I think it's faster and the syntax is easier and it's more reliable, and I think it's just better than...
This was the one where I even wrote my own Python script to do it.
You did, but not for this step.
Oh, okay, that was a different step. Yeah,
we haven't got that far. Yeah,
okay.
I will run through it when we.
It's been a while since I've done this. This is the problem with these things: is you just forget stuff.
Yeah, that's fine. So wfuzz, we used the -w for the word list. And the word list we're going to use is something in user share. wfuzz others common paths, that looks good enough to me. And then -d is the data, as in the post request data, which we can get from burp here and dump in. But what we want to do is replace the bits that we want to fuzz. So in here, we add a... Oh, you don't do carrots. Carrots are for Hydra. This one, you just type fuzz in caps.
So this is similar to in burp, you've got...
Intruder.
It's intruder, is it? Yeah, yeah. So intruder, where you set up variables that where it'll put the words it's running through. wfuzz is basically like intruder.
Yes.
As a utility.
Yeah. But because I don't have the paid version of burp, it would take forever. So that's why we're doing wfuzz.
Yeah.
And then we just add the URL that we want to send this post request to, which we get from up there. We know the host and URL, and hit run. See what happens. Now we get a massive list. It's not too bad because our word list itself is quite short, But if this was massive, we could start hiding requests. So we know for a fact that if we type in, what was it, 1, 2, 3, 4, 5, 6. Let's just kill the proxy for a sec. Actually, that's going to keep having a whinge because it hasn't finished that other request. 1, 3, 4, 5, 6. We get error login failed. And that's what it's telling us here. We've got a response body that's 500 characters, 36 words, 18 lines, and it's a HTTP 200 response.
So a brief aside for application security and login logic. So this is kind of a variation on a user enumeration sort of attack. So the idea is, in this case, it allows us to find a valid account in a massive list because, so notice it's 3 lines instead of 18 lines for the correct value, or 24 words. That's the odd one out. So whoever's developed this has probably thought, if I never return a 400 or a 404 or a 401 or whatever I'm going to return to say you can't log in, if I just return 200s, then the attacker won't know that that the request failed. So if they all look like they went through, they don't know the real account.
Exactly.
So the point here, though, is there's more than just response code to flag on.
Yes.
In this case, the response code is a 302, which means it redirects if the valid's login somewhere else, which is why it's 3 lines instead of 18, because the redirect probably says something like, if this link, if you don't redirect in X seconds, click here.
Yeah. It's probably something really basic.
Yeah, and so the idea is that thinking about enumeration attacks and how to handle authentication logic can get pretty complex pretty quick if you want to be, we were talking about this a bit today, if you want to be absolute in making it difficult for an attacker, this is a pretty obvious flag that there's something there.
Yes.
Yeah.
And the other good thing that WFuzz allows us to do is, say we used a massive word list like rock you, this is just going to sit there when it actually runs. It's loading the Rocky word list, which is probably not a good one to use.
Yeah.
But anyway, let's assume that did something crazy and showed 1 billion results here, or however many lines. There's like 100 million or something. And we wanted to hide all of these requests that we know are wrong. So we don't necessarily know that it's going to do a 302 on a successful login, but we do know that it'll be, say, 36 words. So with WFuzz, you can add the flag -H for hide. It might be caps. I'll probably get this wrong. And then W for words. So we've got L for letters, W for words. I think it's actually H for characters because C is response code.
Yeah.
So we want to hide words that are 36 length, if that makes sense.
Yeah, hide results that have 36 words in them.
And it's not that because it's probably
Yeah, -H is probably like help.
It probably is capital H then.
It's not that either.
This is what I get for not preparing.
There is no plan ever survives first contact with the enemy.
Oh, it's not caps. So the second one isn't capital. It's just HW lowercase. Nope.
Nope. Up-on.
Hide responses with words. Use BBB. Oh, it's double dash. It's not one dash.
Oh, yeah.
All right.
This is the joy of switches for commands.
Yeah. Thanks, Professor Hess, for following and watching us stumble through what we're doing. It's been a while. We're getting back into it.
Normally
this runs smoothly, we swear.
We spend a good hour, and the day before kind of going, what are we going to do? How are we going to approach it? This time, we're just straight into it.
Yeah. So you can see now that works. So we told it to hide everything that was a 36-word response. And in this case, we only get one response back, which is our default, because it has a different word count response. And as mentioned in the help, you can hide C for response codes, L for lines, W for words, and H for characters. Anyway, now that we know that default is the username and password, that will get us a different response at least, we might as well try it and see what happens.
Would you look at that?
And would you look at that? We're in to a giant stock list.
Stuff. But there isn't anything that's of much use there. It's just a list of things.
Looking at this, no, there's not. The first time round, we created a word list using a tool called Cool. Just in case any of these words happen to be a password that we need later on in the future. You're planning me to my new Yeah, that's true. You get to learn a lot more when we stumble through and have to re-look up the documentation and things like that. So it might be for the better.
Okay, so when we did this, we did try a Durbuster to see if we could find anything, and we didn't find anything.
We did that too.
Which means if we go back to the 8080, that was like the next thing to kind of... So the way it works when you're breaking down what to look for, you kind of take a path of least resistance approach. So I've got a track to follow here. I'll follow it until I hit a point where the next step or the options for exploiting that path get... They jump up in terms of difficulty, and you go, well, it might not be this way. What other paths are open to me? And in this case, it's that other service, web service listening on 8080.
Yeah, and that's exactly why we started at FTP. Not because we're going in numeric order of the ports, but because it told us we instantly had anonymous FTP access to a file. And then the next logical step is port 80. We've had a play around with that. So yeah, now we're on to port 8080.
If we jump to port 8080, so we get an interesting password authentication cookie not set. So I suppose the thing to wonder here is, what would it take to set the authentication cookie? How complex would it be?
Yes. So looking at the cookies that we've got a session cookie, which is the cookie that we received after we successfully logged into port 80. Firefox groups the cookies, I guess, in terms of domain name or IP address in this case. So even though we're on port 8080, we're still getting the port 80 cookies.
So one of the things to learn with quirks with cookie paths is it doesn't consider port. It's just domain name.
Yes.
So domain name and URI path, like the path on the right-hand side of the URL, it ignores ports.
Yes, it ignores ports. Yeah. So looking at this, it's telling us we need a password authentication cookie. So we played around with this for quite a while, W-fuzzing and brute forcing different kinds of cookie values. We can use Firefox internal dev tools or something like Cookie Manager or some other plugin. If you don't use Firefox, use Chrome or whatever. I'm sure the dev tools can probably create and modify cookies, and otherwise there'll be add-ons that will also do it. Eventually you get to a point where we find out that it's actually telling us what it needs, and it's looking for a cookie called password. I don't think any of that stuff actually matters, and the password can be those guys, because we're just testing to see if having this, a cookie called password, does anything. And when we do that, we can see that our response actually changes. So instead of not present, we get the password cookie is incorrect, which means we're on the right track.
So another funny thing while CTFs sometimes fall on the more realistic end, sometimes they're almost just puzzles. So in this case,
this was a puzzle.
Password authentication cookie not set, and you think too hard about it, and you're like, oh, what sort of craziness do I have to get up to when it's literally a cookie called password?
And even from here, you see the session cookie and its value, and you think, man, do I have to start hashing different passwords and dumping them in, or what do I have to do now to get something that's a valid password value? And eventually we end up going back to our good friend WFuzz. This is a pretty WFuzz heavy box. Well, it was for me anyway, because I didn't write any custom scripts. So this time we're going to use WFuzz to, instead of fuzzing a post request value, we're going to fuzz this cookie value here. So the syntax to do that is WFuzz-W again, because we want to use a word list. The user share word lists was under WFuzz. The common password, stuff, sorry, I pushed the wrong button. The common passwords list worked for us last time, so we're going to try it again here. Instead of -D for post request data, we do -B, which somehow has something to do with cookie. It's probably in the documentation if I actually read what -B stands for. Is it up here? No, -B is just cookie. So we're using -B to set the value of, well, the cookie and the value that we want. We know the cookie name is password, and we want that to equal our fuzz. Then we do the URL that we want to hit. Oops, with 2 T's instead of 2 P's. 10.10.10.86. And their commas, not full stops. That 80.80. There's no other, we're not in a path, we're just in the root level, so we can leave it at that. Let that run, and this time we get a bunch of responses too. Again, if it's hard to figure out which one's the one that's different, we look at 1, 2, 3, 4, 5, 6, 7, 8. Generally, the ones that repeat a lot are usually the ones that are incorrect. So this time we'll hide, say, 324 characters, and we're going to get it right first time this time, because we learned from last time that it's /, H for hide, and H for characters. And we're going to hide 324. So letting it run this time, we see that we get a different response for secret. Going back to Firefox, we change our those guys value to secret, refresh the page, and see what happens. Can close that now because we're logged in.
Very nice.
We got a new form again. This time it's not a login form. It looks like one, but it's not. We get a status of cache engine online, TCP sockets. We've got a port and a line to send, and a submit button. Thinking of common TCP ports, first one I thought of was 80. A line to send, we can send those guys again just to see what happens when we pass it a TCP port we know about. And we can see that it runs some kind of request against that port, gives us a bit of information, and it tried to run those guys or something like that as a command line argument, or who knows what it's doing in the background from this response. But we do get a response. Testing, say a random port number that probably doesn't exist, to see what kind of different outputs we get, and we get a completely different response of invalid port. So it looks like we can use this website to see if there's any other ports open, presumably on this box that's running the site. So to do that, we can see that we actually have the port and command up in our GET request. So I turned to WFuzz again to fuzz those two values to see if we can get some kind of response or enumerate some more ports that are only open locally and not open to, say, our Nmap scan.
Yeah. Also, just as a note, my previously when I mentioned Python script,
I think this is where you used it.
that was the cookie thing. So that was just the last step.
Oh, was it the cookie one?
Yeah.
I thought it was this step.
No, it was
My
the
bad.
previous one. All good. So that's in the write up. So feel free to look at the write up. All it does is some multi-threading to speed up getting the job done. But anyway, onwards.
Does it work? I can use it.
No. Don't worry about it.
All right.
It's just a note that if you're curious, it's there.
If you want, we can run through it later.
Yeah.
If everyone wants us to. Okay, so yeah, wfuzzing the get parameters of our TCP socket tester. We know that it uses cookie auth, so we don't have to worry about.
Actually, no, sorry. Correction. You're right. It was this step.
What was this step? All right.
I was very wrong.
That's cool.
Yeah.
Let's Vim this time. What should we call it? TCP.
.py.
TCP.py.
Yeah.
Because we are going to test some TCP.
Yeah. So the idea is we want to run through every single port on the box through the local loopback to see if anything's running.
Yes.
I was confused because I saw the cookies password secret and thought, oh, I must have had a massive dictionary of all the combinations that I was running through. It's been so long since I did this, I forgot what my own stuff was.
No, so that's just because we already know that the cookie is password secret.
Yeah, as soon as I saw the next thing, I was like, oh, wait a second, yeah. I know what I did. Apologies, everybody. So all this does, quick run through. So on that web form, we can say what ports we want to try and scan to see if anything's listening locally. So for those of you probably aware, when you've got a computer and you look at the interfaces on the computer, you'll see your actual network interfaces, like if you've got a wired adapter and Wi-Fi and VPN tunnels and I don't know, quirky, 5G or whatever. But you'll also always have like a loopback interface with the address 127.0.0.1. It's a different address for IP version 6, but same concept. When you start a service listening, some applications or services or servers let you configure what address or interface to bind on, so what to listen on. If it's only listening on 127.0.0.1, it'll only respond to local queries for stuff. So
this one's actually doing. And that's my burp proxy.
Yeah. So I can't access that port unless I'm on his computer. So if I was on the same network as him and tried to access 88 on his computer, nothing would respond because it's only going to respond if it comes from, or it comes from that address.
Yes. But if I start a netcat listener and then rerun the same request, this time we get a 0000443, and that's my netcat listener that anyone on the same network as me will be able to see, like you were saying.
This script does then is run. So if we go back to the website or that form, so all this script does then is automate pinging all of those sockets to see what is listening locally. Yes. So it takes what is it, 65533, 65535, that's right. Split that up into even chunks I'm using a library called multiprocessing, which will then take those chunks and evenly run through them as multiple threads to speed up the process. So one loop running through 65535, let's say it has to take a second per loop, is going to take a long time. Split that out into, how many different pools am I splitting out to? 50. That into 50 running in parallel, and the total time is going to be a lot less. So it's one of the things to note if you're ever writing some automation is understanding concepts like multi-threading, and then understanding that Python abstracts multi-threading another layer. You can use the actual multi-threading libraries directly, but that's a bit tedious. Whereas in this case, it's a relatively simple function I want to run. So check, which all it does is try the request, get the response, print out what the response is. And so pull.join then takes all of those results and presents them back. That's all it does.
Nice.
Yeah.
So we're gonna right click that and give it a go. Oh, hang on, it's Python 3.
Yeah. You also don't need to exclamation mark. Just WQ will get the job done.
Why can't I control C anymore? I think I broke it.
Yeah.
I broke it. That can just die in the background. Python 3 tcp.py. Okay. So
do anything particularly nice with this? So it the first one will always give missing oh, that's right. It just searches. Yeah, the first one will always give missing parameters because port 0 isn't really a valid port to try. I forget what it runs in the background, but I think it's just. Is it just running Nmap on the server? Anyway, port 0 is not really a port. That's why that one errors, and then it only shows ports that return to 200 or
return a 200 response code. Yeah.
So we should see something very similar to our Nmap results.
Yes. Yeah.
But we should also see at some point something different show up. So 11211.
And that would be this 11211. If we go back to our Nmap scan, 11211 did not show up. If you do an all port scan, it also doesn't show up. That just takes ages, and I didn't prep it. So
normally quite a sensible measure when securing stuff. So for example, you've got Redis or what's that, Mongo on your server that your app talks to. Rather than making Mongo or Redis like world accessible, you just bind it locally, and your application locally can talk to it. In this case, the challenge is that someone's put something on this server that gives you like bash command injection, which is effectively what we do with this next step, I think.
Yes. So looking up port 11211 to see what it is, we end up getting, hopefully it's, top result. Memcache, and it's actually, I mean, this might be a little bit of Google targeting me because I generally only use this to search for exploits and vulnerabilities. So it's gone straight to a Memcache attack page, which runs through how to do certain things against Memcache. I don't think I actually read this. I just used it to determine that we are running Memcached.
Case, we don't even have to find an exploit for Memcached. It's because of the way it's configured. We can just I think it might be Nmap that they've got hooked up to that form. Either way, we can interact with it through the web. That
I did. Okay, in the write-up, I actually saved the link. So here we go. We go to the documentation for the version of Memcache that, I don't think that's even the version of Memcache that's running. It just gives us all of the commands that work. So reading through, when we try and run, say, our those guys command, we get an error because that's obviously not a valid memcached command. But if we run something like, say, memcached XP time, it's probably going to be easier if I dump this into burp. So just so that we can keep repeating a bunch of requests, we'll go back over to our proxy and forward everything and tell that to go away. Cool. Now when we submit this, we can send that over to repeater. Go. Cool. And we get an error. Awesome. That's probably not how you use that command. It probably needs some kind of...
Remember just looking up the like settings or something like settings or stats from memory. if I look at
I
the
think we
handy
just run
dandy
gets.
guide to the bit we're up to, where is it? Stats cache dump.
Stat.
Yes.
So looking at the command, no, it probably doesn't matter, does it?
There we go.
So stats is a valid memcache command, and when we run that, we actually get a reasonable response.
Yep.
Reading through the documentation again, it's actually not that long, but I think we went into all of the links for all of these. No, there it is. There, stats command.
Memcached is like a, well, I suppose it's in the name. So it caches data, and it sits in memory. So you can interact with it over TCP. So it's relatively simplistic. There's no fancy protocol. You just send it the command you want, and it sends you data back. It stores things in, I think they were called partitions, weren't they?
Yes.
Partitions or shards or something. And so there might be some useful data in here for us to continue progressing through this box. But to do that, we're going to need to see if there's any data sitting in memcached. So I think the first step was to get a list of what partitions there were.
Yes.
So there's like it's stat and this was where we just spent a lot of time looking through the doco trying to figure it all out.
That's right. It was stats. They're called slabs.
Slabs, that's right.
Stat slabs.
Yeah. And that tells us, right, so we've got, if you go back to the results in burp.
On this page. It's on a different page. Yep.
We've got two slabs. So we've got 16 and 26. They're the IDs for the slabs.
Yes. Now that we know the IDs for the slabs, we can look at details of those slabs directly. So we can run just stats against the ID. Start at 16 because it's at the top. We get an error. I don't think it's stats. I think it's just stat because you know the exact thing.
Yeah.
No. Oh, it's cache dump.
Yeah. Cache dump, mate.
Cache dump 16. So this will dump the bad command line CACHE dump 2016 0. I don't remember what the trailing 0 is for, but you need it. I probably could have linked to a better
run through. There's not much doco on it. It's a thing where
it's one of those things.
In case you don't really worry about how it actually works.
Yeah.
So yeah, the 0 I think is like slabs. I think might have the ability to be broken up further. But either way, this gives us what we want. So this is part of the joy of CTFs and pen testing is you just have to know enough about something to get the job done. You don't have to be an expert in it. So if we do stats cache dump 0, we get item stock, but we get no other data.
Yes. So that gives us some kind of name. Thinking back to our old website, it was a stock list. Sorry, I just had to cough.
All good.
So that's 16. If we have a look at 26, just to see if there's anything different in there, this time we get a list or a cache of users, which sounds a whole lot more interesting than stock does.
We should be able to go either get stock or get users. They're the two commands to actually get you the values in the cache. So if we try get items, so and run that. So this is what flummoxed us for a while on this one. We were like, there's nothing there, but there's in the website. And if you go get users,
that's not what I used, is it?
Get users and go. There's nothing there. Yeah, that's what you used. So this we were like, what the heck? How does this even work? Is this a dead end? Because we initially thought that the stock list app gets its data from the cache.
Yes.
When in actuality it doesn't. it puts data in the cache when you run the page. So if you refresh the page and then go get stock, we should get, if I've remembered this correctly, data.
A bunch of data.
So what normally happens when you run a cache is the cache will have an expiry time. This is more dev stuff than security stuff, but it can sometimes be useful. They've set a super short expiry time for this cache. I think it disappears pretty quick from when we're playing around with it. So the idea here is that
an autocomplete.
is the app pulls data from the database, so a stock list and a list of users, and populates the cache. And if you refresh in enough time, the app will just go to the cache and go, "Do you have my data? Give me my data." But when the cache doesn't have it, the application then goes to the database, pulls the data back, and caches it again.
Yeah.
You use this when you've got like lots of repeated requests. Caches are normally in memory and very fast, with databases can still be fast, but caches are still faster. So the point now is, as you can see, we've got all of the users, because it caches a list of users and a list of stock. I'm not exactly sure the reason why it's caching. Oh, I suppose we logged in with default. So it's caching everything from the database.
Yeah. Yeah, I'm not sure why they would do this, but it's probably a bit CTF-y. It's probably not something that a real life app would do.
Surprised. I'm trying to remember. I didn't use Burp to get the data there. I think I used curl or something to get it.
Yeah, I think I just ran it. You can run it straight through the site as well, and you get a cleaner rendered list. But it's a JSON response is what we're actually getting. So we can run through and clean that up. And let me just copy paste it from somewhere else, because there are a ton of users. And I think I just used like a JSON prettifier online thing to get it. That has finished running. No, it's still running. Not anymore. So we vim, I don't know, we'll call it hashes.txt, because we think it's hashes. And it is a almost 500 line list of username, password, what look like username, password combinations, or username hash combinations.
Yeah, I wrote like another quick and dirty Python script to take the JSON and get it into the right format. I think you had a different way of doing it, but next step is, I think, Hashcat, isn't it?
Yes. So I actually, because there's so many of these, I pulled it out onto my desktop, which has a dedicated graphics card and is better at cracking lots of hashes than my VM running on a little laptop. So, I mean, we can see what happens. We'll just run it and see what happens. So it was... so, yeah, running hash ID against any of those hashes. If I just say head hashes.txt and grab one of those and do I think it's just hash ID in the hash, isn't it? It thinks it's some kind of MD sum hash. So generally, I don't think I've ever actually seen an MD2 or 4. So for capture the flag stuff, I always assume MD5. It's quite common. And Hashcat's really quick at getting through that sort of thing. So Hashcat, we want -m for the mode. The mode for MD5 is 0. The files we want are called hashes.txt, and the word list we want to crack against is user share. No, it is a word list. Oh, not work. Word lists rock you. Running that. I have no GPUs on this VM, so I can't run Hashcat.
Yeah.
Did I look up the? I don't think I looked up the John equivalent of cracking MD5s, but you can look it up if you want to do it.
So John the Ripper is another alternative, uses the CPU. So we use Hashcat because we both have I think 1080 Ti's, which smash through all the CTF like lists of hashes you end up getting on boxes pretty quick. I think this one was like sub 1 second.
Yeah.
Whereas John the Ripper's CPU focused, and you have to spend time getting stuff in the right format, and it absolutely sucks. So we're like meh, Hashcat.
Yeah, pretty much.
The challenge with Hashcat, and I've got this thing too, I always have to take my hash lists out of my Kali VM, just run it on my on Windows with Hashcat so it can use my graphics card, because you can't really if you've got a single graphics card system, you can't really forward them through to VMs. I think if you've got more than one graphics card and you've got the right virtualization software, you can forward it through. But it's not that hard if you've got copy and paste working in VMware or VirtualBox to just copy out your list, crack the hashes, and get what you need.
Yeah. So
You going to go for it?
I'll just do a quick run through. I think with this you do the word list first. No, not opt, user. Share, word list, rock you, and then it's in home, doc, hack the box, retired, dab, hashes. Okay, that didn't work. I don't know then.
Yeah. Every time I've come to have to use John, I've just skipped it. So
yeah. If I prepared it and I knew what it was. Oh, you have to add dash word list. Alright. Nope, apparently not. Alright, never mind. I don't know how John works. Yeah, generally I don't use it. I use Hashcat.
Yeah.
Because it's far simpler and far faster because it uses GPUs.
And the jumbo version, because there was one thing we needed it for, I couldn't even get that working. Like some of the dependencies I just couldn't find.
Yeah, this was a pain in the ass to get working.
Yeah. Anyway, we run that through and we get a list of results that looks something like, if I just vim into anything temporarily, we get a list that looks something like that. We thought about scripting this out, these username password combinations, to try and essentially like Hydra or WFuzz SSH logins, because that's the next logical step in terms of open ports on the box. But because there was only 12, it's quicker to just manually try each one until one of them worked. If we knew what we were doing or were fast scripters, I'm sure it probably wouldn't have been, but you know, it would have been a good side project, but we never got around to doing it. Eventually, if you do that, you end up getting the Genevieve one is the account that actually works, and her password was Princess1, I think. Yep. Oh yeah, there we go. So all of this effort to get to what I think was the most fun part of this box.
Yes, true.
Which is about to come up.
So we can see from that, we can read the user.txt. We're halfway there. Looking at the user's home directory, there's no bash history to help us. Nothing else in the user's home that looks useful. Typically, when we are fully SSH'd on as a user, we try sudo-l to see if we've got anything running, anything that we can run as sudo. Type a password in. We can see that we can run user bin tryharder. I'm not sure if I want to bother running through that. I mean, I can just... never mind. Oh, I didn't copy sudo that. There we go, copy that time. It looks like we think we're in as root on dab, so we go say ls, we get a seg fault, looks like it's broken, and then that would be too easy. Try something else.
Yeah.
Quick, I guess troll rabbit hole. If you really wanted to, I think we did it eventually actually look at this binary, and it's literally all of that is hard coded. There's no actual fault in the app or anything like that. It's just hard coded to keep
running. If it was
running.
a real segmentation fault, you wouldn't have seen that would have been too easy. Try something else text.
Yes. The app would have actually crashed.
It would have just killed itself. Yeah.
The next thing we do in terms of our enumerating a box once we're on it is look at the file system permissions, searching for things like sticky bits and stuff like that. So we do that with dash find, and we're finding everything under the root directory. Perm for permissions, and 4000 is the sticky bit permission.
So to clarify, sticky bits hark back way back to Unix. The idea was, let's say you've got a text editor and you want a normal user to be able to edit configuration files, but you don't want to give them root permissions. So the idea is that the sticky bit then enables other users to use the application with the permissions of the user who created that, who set the sticky bit. So if that was root, that application can write anywhere root writes.
Yes.
Super old versions of Vim and VI, that meant you could like do the breakout to just run bash commands and be running as root. Newer versions are smarter, and when you try and break out, so you do the exclamation mark to run commands, it'll use your actual user context. But it's still a useful thing to find apps that have this sticky bit set, because you can abuse that for all sorts of fun and profit. In this particular case, it's a particular binary, isn't it, that we're after?
Yeah, so if we look at, I don't need that tab anymore. If we run the same thing against our local file system, just to compare results on what could be standard, that actually takes a whole lot longer, and that might be a bit of a giveaway. But essentially, oh Jesus, heaps on there for like VMware and stuff. All right, maybe do that on a full blown Linux install rather than like a VM. But essentially, what we're looking for in here is binaries that don't look like they're out of the box. Even so, there's a site called GTFO bins, which, if you do find apps that have set UID bits or odd looking file permissions, oh, I can't remember now. What was that other one that we did? Not last week, the week before, that had ACLs. That's the thing.
Yeah.
ACLs and things like that. Sorry, I'm still getting back into the security mindset.
That was looking at capabilities and stuff.
Capabilities and things like that. Yeah. So basically, with this website, if you type in a binary, like we have ping, there's nothing useful that ping can do. What's one that it gives you? So say you found curl in this list of sticky bit, like it had the set UID on it. This website would tell you everything that you can do to exploit that. So you can use set UIDs to read and write files, create a set UID backdoor, things like that. So this can be handy. I think I did actually use this to run through a lot of these. Yep. Until eventually we get down to myexec, which is a non-standard looking executable file name. We try running it to see what happens, and we get
I got
to sudo it. No.
You don't need a dot. That was why.
You just run it. That's
Yeah.
right. We get prompted for a password. We can try Princess1, and we get invalid password. So it's an app that's doing something. Looking at the file permissions against this, we have read and execute permissions. Well, we have read, everyone has execute, which means that we can steal this file, run it locally, try decompiling it, reversing it, playing around with it to see if there's anything we can do to exploit it. A few different ways we can get this off the box. The easiest way, since we're SSH'd in, would be something like SCP, but we also found that you can FTP in with the credentials and browse around the file system and download it through FTP as well. But I'm just going to run it through SCP, and that's the syntax to do it. So with SCP, we use our SSH credentials. The first colon is the file directory on, if we're doing it, how do I explain this? If it's on the right hand side of our credentials, then we're talking about performing tasks on the server. If we had it on the left hand side, we would be talking about copying files from our local machine onto the server. Yeah, that makes sense, doesn't it? Yeah. Yeah, so all we're doing here is telling it, log in as Genevieve, find this file, download it locally as this file. And we've got
Sweet. Let's have a squiz.
having a squiz at it. We run so got execute already on it. Yep.
Now you need the
You
dot.
need the dot, yeah. I knew I needed it somewhere. This isn't gonna. I did it bad and didn't. I think it's in. Why won't that type? No, it's called.
So what happened is there's a particular step here, and if you've already gone through it, so you've like done the box in the past, like what we've hit, the thing actually works like it's meant to. So just getting back to the state where it would be.
Yeah.
So-
that was some cleanup from the first time round that I didn't do.
So what this app does, from what we can see, is it needs a password. As we saw there, once Jacob had copied it to its box, it still wanted a password. So there's a good chance it's in the app itself. So if we decompiled it or look for strings, we might find the password.
Yeah.
The other thing we see there too is it's looking for a specific library, which comes in handy very shortly.
Yes. Yeah. So we're looking for a shared library called libseclogin.so. Heading back onto the box, we can run our find again. Again, / we do dash name, quote libseclogin.so, type F in case we care, and pipe any errors to dev null. Ooh, type with an E. Should be right. We have permissions to see it, don't we?
Uh-oh.
Maybe I used locate, not find last time. Anyway, we can see that on... Man, this is why we need to prep more. Anyway.
What happened?
It would just run smoother.
Oh, good. Sorry, I thought something else happened. Cool. Yeah. So we've got the library. So let's have a look at that.
I clearly don't know my find command syntax well enough anymore. I thought it was that, but anyway. Locate works just as well. So we know that it needs this file. It only exists in one place on this box. So what we're going to do is use our scp command again, and this time we're going to copy off, let me copy paste that, user bin libsec login, and I'm not going to put it there, I'm going to put it in the exact same place. We log in, let it download, and now this time when we run the myexec locally, we can see that it, instead of having a hissy fit saying that it's missing the library, we actually get the password prompt. And we get the same functionality that we were getting on our target. So now we can sit there and try and decompile and debug this app to figure out what's going wrong. Because it's a Linux app, and it's only doing, like you said earlier, we assume it's only doing a basic string compare against user input to figure out the password. The easiest tool that I've found to look at this sort of thing for Linux binaries is a tool called ltrace. Ltrace, if I can type. And when we run it, we'll see what it does. So it will run through and show you the code that it.
So as the application's running in memory, so if you look at a lot of like decompilers, if your app's in any way like packed, like with a packer, it can be hard for a decompiler to do anything meaningful or even strings. What this does is as the app's running, print out, in this case, the name of the function, some memory addresses. In this case, we've got the symbol, so the printf enter password. So if you try typing something in and hit enter, so what we see is there's a string compare operation. So this is in C. You've got an operation that can compare two things, and if they're the same, oh good, it'll return true, or 1 at C. It's probably 1. Yeah. That means that's the password. So now if we try that password, when you try and run the thing, still using ltrace. So ltrace runs the thing in real time.
Yes.
Ltrace executes the program. It's super ghetto. You can use more complicated debuggers, but ltrace is quick and dirty, and
it's a super quick and dirty debugger.
Yeah,
but that's not even really a debugger because you can't. I don't
you
think
can't
you
pause
can
the
set
execution
breakpoints
or
anything like that. It just prints out memory and code. Yeah.
So what we get is there's a function. So it's like sec login is what it's trying to call, and then it outputs the value sec login called to do placeholder for now function not implemented yet. So in this .so file, there's meant to be a function that's run. That isn't implemented. So what we effectively have here is, I suppose the next step of the attack is to figure out a way for us to build our own that libsec, what was it called again? Libsec login shared object file. So shared objects or .so files are like DLLs on Linux. They're static libraries that you can, static's the wrong word to use. They're libraries you can dynamically link to, and that's a keyword here, yes, from your application and run functionality within. It's the same with DLLs on Windows. Dynamic linking means that if your application uses, I don't know, like glibc or something like that, and there's an update to it, your application, without needing to be updated, uses that updated functionality, which can either be a good thing or a bad thing if it's updated and it breaks how your app works. It's the same with like Java dependencies and all that other stuff.
Yeah.
But what we can do here is, because it's dynamically linked, is you can play some funny business with linker injection. I think it's called linker injection. Effectively, where we tell the linker that our library, even though we can't overwrite user lib, we can tell the linker to prioritize our version over the system's main version. So we've just got to build our own library, test it out, get it on there, and then there is a fiddly bit with this particular one with, I think, how you do that linker override.
Yeah, so we have no permissions to overwrite this file, but we can tell the app, instead of loading this file, load a different one, which we are going to write now. The way you check that sort of thing initially, in terms of if you are able to, I guess, hijack the dynamic linking, is with LDD. I'm not sure what that actually stands for. I never looked that up. It was part of a different write-up about doing shared object library exploitation. I never actually looked up what LDD means. Use a bin. Why isn't that typing? There we go.
LDD. I'm just looking it up now.
So basically, when we run LDD, the dynamic libraries that it is linking to currently is this Linux VDS, libsec login, libc.so, and the location that it's getting them from. So we can see it's currently getting it from user libsec login.
In every binary, there's instructions for what external libraries it needs, and LDD basically reads that data.
Awesome. Thanks, Professor Hass, for joining in.
Have a good one.
Yeah, have a good one.
LDD reads that dependency data in the compiled executable, and then tells you what library it's going to load from the operating system. There is a whole bunch of configuration for paths to look in and what should overwrite what. So it effectively goes, I'm going to load this one when this application runs.
Yes. The place I went to get all this sort of thing, I'll just dump 2 links on the page, because otherwise it might get lost in the write-up or something. There was this blog about doing privilege escalation using our dynamically linked shared objects.
Yep.
I read through all of this. Basically, it runs through and says, it shows how the operating system finds a shared library in the first place. So we can see it looks in directories, it'll look in environment variables, which is what those are. It'll look in more environment variables, it'll look in certain folders, which ours happens to be sitting in, and then it'll look in anything within the
first one there is, so that rpath-link, I think, is that thing in the binary. So if the binary stipulates a specific path to load from, it'll load from there.
Yeah. The most important thing about these are they are set at runtime. So I don't think you can actually hijack these. If it's loading the libraries through these rpath links, I don't think you can actually hijack those, because they're done at runtime rather than at like from a file path or something like that.
But the funny thing here is /lib and /user/lib are a fair way down the priority list. So there's opportunity to inject. The other thing to note is in Windows land, similar problem. You've got an order of priority. So the first place your application will look for, or the whatever the equivalent to LD is on, or the linker on Windows is, will maybe it's just in the kernel, will look in the same directory as the executable, and then it will look in system directories.
Yes.
So that has been an issue in the past, where if you can get yourself a malicious DLL in the program files directory for the app, it'll use the DLL there rather than the correct system one. That is also, I think, has been ways to get certain functionality working for certain apps that require older versions of DLLs. So you just stick the old version in the same directory and it all magically works. Either way, the thing is to note that there's like a kind of a hierarchy of priority here for where it looks.
Yeah. So working our way down this list, those are environment variables, so we can echo them out to see if they currently have any kind of value. And just having a quick look, we can see they're all empty. With environment variables, sometimes we can actually set those. So if we run export, say the top one, copy, paste equals, I don't know, a path to those guys. And then if we try and echo that out again, this is just to test if we are able to change these values and potentially hijack the path.
Which we can.
And when we do that, we can see that we can.
Environment variables are a user can override them.
Yes.
So it doesn't matter what they are. 9 times out of 10, they're going to break functionality because they're set to something that's next to useless. But
yes. Working our way down, we already know that it's in 6, but looking at our ld.soconfig just to see what might be in there. We can see that it is including anything in this directory that ends in .conf. So if we ls this directory, we can see that there's a libc, a test, and some, I don't know, I'm pretty sure fake and the 8664 are standard ones. Cutting some of these out just to see what's in them. We can do the test one because that always looks interesting.
That's the interesting one.
We can see that it will read /temp for libraries.
So we went through a lot of pain to get to this point.
Yes, we did.
We tried that write-up we found. We tried a bunch of stuff until I thought this test.conf was from another. Sometimes I forget to reset the boxes, and so I thought maybe this is from another a user on Hack the Box just trying something. As it turns out, it came with the box, and that's a major hint for where we need to stick our shared object file.
Yes.
Anyway, so we should probably get to the bit where we compile our library, test it, and get it all working.
Yeah, so now we have a pretty good idea that if we need to, we can set an environment variable, or otherwise we've got this temp directory that it could potentially load shared objects from. So when it comes to sticky bits, we have it's been too long and I can't remember what it's called on my box, so I'm just going to copy paste it. There is one that comes with Kali somewhere in one of the examples. I think it might even be part of Metasploit, but there's a binary called setuid.c, I think, or something like that. Oh, maybe it is a custom one. I always thought it was. Cat that. Oh, don't cat that.
I'm pretty sure we wrote our own.
Yeah.
Effectively, what this does is a standard IO is just a standard C library for input-output. Set UID sets the user ID that the application will run as, if it's allowed to assume that ID. So if you don't have the sticky bit set and you try and run this, it's going to error out because the kernel won't let it. Set UID and set GID are kernel functions, and the kernel will go, you don't have permission to set yourself as the user ID of root or the group of root. But once that's done, it'll spawn bash. And drop you on a bash prompt that has root. That's all system does, is it'll just drop you out to bash.
Yeah, that's all it does. Now that we have that, we need to compile it. We use GCC. Because we don't want it to compile into a executable binary, we want it to be a shared object library. We use the -shared. I can't remember what the FPIC stuff means.
It's all compiling options.
It's all compiler options. The -o is the file name we want to call it. We don't want to call it libc. That must be an old one.
I will look at what -f does.
So we know that we want to call our malicious library libseclogin.so, and we want it to compile from our libseclogin.c. Running that, it throws a few warnings. That's fine. We ignore warnings. We only care about errors. So now that we have a potential shared object library and we've got the myexec locally, we can test this out to see if we can get it to work. Currently we have our default libsec login in the directory it's looking in, which is the user share bin, whatever it is. And we've got our custom one in the same directory as the executable. So like you were saying, if the binary happens to load from the current directory first, when we run myexec, it should spawn a bash prompt for us. myexec, I can spell, crap, and I forgot the password is.
Okay, so f-fpic creates position independent code. Now I'm going to double check what position. So this is the other fun part about doing what we do is you learn tons of stuff. Like, yes. So when I was doing the last stream we did, where we used MinGW, which as I learned is literally just GCC, but designed for compiling on Windows. And then, funnily enough, we were using MinGW back on Kali. It had been exported back, but okay. PIC executes properly regardless of its absolute address. It's commonly used in shared libraries so that the same library code can be loaded in a location in each program address space where it will not overlap any other uses of memory. Okay. Was also used in older systems lacking a memory management unit. Okay, so it's basically just setting it up so that it doesn't care where it is in memory.
Fair enough.
Bam.
Okay, so what I just did then was I looked locally where it's pulling this library from. It's pulling it from libsec login. I just made a backup in case we need to go back, which we don't, but I did it anyway to be safe, in case our exploit didn't work. Then I copied our compiled shared object library into the lib folder and ran our app. And when I ran the app, we can see that it spawned a bash shell for us. So now we know that we can, if we can get the app to run our library instead of the library it's currently running, that we can get it to spawn a shell. So that's our next step. First of all, we need to get it on the box. So this is where we can use the SCP the other way. Where is it? Home, docs, hack the box, retired, dab, libsec login dot so. Genevieve, I think I spelled that right. And it's the right way around, isn't it?
Have you forgotten how to use SCP?
No.
I
thought it went left to right, like
I raised an eyebrow when you said this is how it works earlier, and I was like,
That's how I thought it worked.
Oh no, yep. There's no, so it's SCP and then your file, and path your file, then space. So you need to add a space after
so you do a
the
space,
dot.
not a colon.
Yeah, there's no colon there.
See,
There's
so I was close.
yeah. So the colon is there, and then you got to get rid of the colon after the libsec logon.so, that other one.
See, I was right with the left-right thing. I was just wrong with my syntax
Format.
of where the thing goes.
Get it going, boy.
I haven't forgotten all of it, but I've forgotten some of it. That's what I get for taking a break.
Oh, yeah.
Was it Princess 1? Okay, I can't save it to wherever it's trying to save it to. So I should try saving it to /temp. Because it's always a safe bet that everyone has write permissions there.
Which is where we think it might need to be anyway.
Plus, we think that's where it might need to be anyway.
Yeah. Is that the password?
I don't know. Is that the password? I thought it was Princess 1. Let me go back to...
There's no demonstration like a live demonstration.
That's it. Guys. Oh, I spelled it wrong.
Oh, genius. Oh, good. Don't worry, guys. We're almost at the end.
It's not Genevieve. It's Genevieve.
Yeah. I love it. I mean, this is a classic example of AppSec done well. It'll at least go, yeah, sure, I'll let you try and log in as that user. Password incorrect for a user that doesn't exist. That's a good thing because it makes it harder to enumerate. Because if it said, oh, that's an invalid user. I mean, let's be honest though. Every single Linux box has root for a user.
Mork was on it. I wasn't.
Good work.
It took me a while.
Good work. I hope you dabbed.
Yeah.
For finding that.
Yeah, that deserves a dab.
You deserve it. Treat yourself.
Treat yourself.
Okay, that copied, didn't it?
Yep. Heading over to temp to have a look. We can see that we've got our libsec login.so over there.
Do we?
Yeah.
Oh, okay. My bad. It was just green. It's like it just blended in with the user prompt. Cool. So, let's just jump straight into it and try running our myexec.
Yep. So we try running myexec directly now. Where was it? There. User bin myexec.
Yeah.
That button. What? Why is paste screwing up for me today? Damn it. Now I need that secure login though too.
Down.
Down.
You've already got it there. Yeah. There you go.
Okay, we can see that it didn't call ours. It still called the other one. And running LDD again against user bin myexec. We can see that's because it's still looking in
that directory.
Yeah. So what we want to do is make it so that instead of user lib, it is /temp.
So there's still something else we have to do.
Yes, we still have to do that. So the first thing we have to do is create using ldconfig, because our ldconf.so says that we can use anything that's in this directory, which says we can load any libraries from /temp. We use ldconfig to allow. Now I'm going to believe this is what this means. We use ldconfig -l to allow apps to link to this shared object.
I'm double checking. I'm just doing a quick.
That's my understanding.
Yeah, I remember getting to the end of this and then understanding what we did, and then 10 minutes later being like, I can barely comprehend what we did.
Remember. Yeah. I think +x /temp Oh, does this wipe temp every so often?
Potentially.
Well, my LS? Yeah, it's gone. All right, I don't remember that happening last time. So, where's my secure copy? Here. Let's just keep a backup in. This should save it to the home directory now that I've spelled their name right.
-L.
Yeah, cool.
Manually link individual libraries.
Yes.
So effectively, you're registering a library
Cool.
that can be linked to.
Yeah.
So you're instructing ldconfig that whenever you see an application try and load libsecconfig, load this one instead of the one in /user/lib.
Yeah.
ldconfig is a powerful tool that we've barely scraped the surface on.
Yes.
Same with LD in general. Like this is you getting to fairly low level stuff, and this is the sort of stuff that moving past kind of web pen testing and taking advantage of config errors on servers. This is kind of the next level down.
Yeah.
Kind of alongside like needing to understand buffer overflows and stuff.
Yeah.
Like, yeah.
Yeah. So basically, we use the -L to say you're now allowed to link to this library, and then we use.
Also, no, we're not saying you're now allowed to link to this library. You're manually saying this library is here. So it's not that you're allowed to link to it. It's that it'll go right. LD will load that version rather than the other version.
No, that's what this step does.
-F. What does -F do?
So -F tells it use this config, which says use temp instead, because we've said. So this is how I understood it when we went through it. We used -L to say this is a linkable shared object, but then when you run LDD against it, it still looks in user libsec login. So you have to run the -F to say instead of using the current config, use the what was it, ld.so.conf.d.test, and now that will say instead of using the default or whatever your current
yes
path is to get libraries from, use this path instead, and our test.conf says go to temp.
Okay, yeah.
So that was my understanding of it.
The problem we're running into trying to explain this is there's so little. Like you can find the ldconfig man page, and you can go through like mailing list trails where people explain this stuff, but there's no nice, simple style write-up of like this is how LD works and this is what these flags actually do. So we have to infer based off what we can see. So hence our little aggressive debate just then.
Yeah, so you can see that without the -F telling it use this config, it doesn't link the executable itself doesn't actually link to our temp.
So the first one kind of registers that as an option, and the second one says look in this directory instead of the other ones that you configured to.
Yes.
Or use this config file. Because we can't write to that directory, but that config file is already there.
Yeah.
Cool.
So now, fingers crossed, when we run user bin myexec, we enter the password, which I'm going to copy paste again from there because I never learnt it. Oh, why would you do that?
Uh-oh. This is fun.
It hasn't been deleted, has it? Shit. It's been deleted. That's why. That's fine, because that's why I saved it to the home directory.
This video is not demonetizable on YouTube.
Oh no. Whoops.
Oh no, I'll just like bleep it.
Because we have all of our videos on YouTube monetized.
No, we don't. We don't have enough. You've got to have like enough like regular views and stuff before you can monetize stuff. But man, when we do, we're going to use that $2.50 in like YouTube ad revenue to, oh man,
There we go.
literally buy a macchiato.
So what happened there was it tried to look in temp libsec login. It didn't exist because there's automatic cleanup happening. So it fell back to the previous configs, I guess, and just found the one that does work.
Yeah.
Or it worked its way down that little list and said look in.
Fall back to the previous configs. It fell back to the default.
It fell back to the look in lib. Yeah.
Yeah. Anyway, we're root now, which means we can get that juicy flag.
Yeah.
There's also the user flag that you can get as Genevieve.
Oh yeah, I did that when we first SSH'd in.
That's good.
It's up here.
Someone's catching up, been paying.
Yeah. We headed that before. So now we can cd to home. We should get into the root directory this time. Nope, it still thinks we're Genevieve. All right. We're not actually root. We're running an app, and we spawned a bash instance, but we're still Genevieve. So when we run commands like go home, it's going to Genevieve's home.
Yeah.
But we do have permissions to read and write to the head-c. Well, so talk and type at the same time.
so the app is still looking at, I think, the like bash context for Genevieve rather than root. But
yes, and that's what the setuid stuff does.
Yeah.
Cool. And then that's it. We have the flag.
This one was actually a pretty fun one because it's that nice type of CTF where you've got the different steps. So you mental blanked. So you've got that first app feels like a bit of a dead end. You go looking at the second one on 8080, which is that memcached, and you sit there and you're like, why can't I see anything in memcached? Then you realize you have to load the other app to update the cache to then view the stuff, and then you get the creds, and then you got to crack the hashes.
Yeah.
Get it as Genevieve, and then you've got this discovery about how exactly to bust the privesc via this libsec login.
Yeah.
And that last step was the most fun because that was kind of where we learnt about, like, when you're learning kernel stuff in Linux, it's generally stuff that's going to be universally applicable. Whereas learning a little bit about memcached, it might pop up in something and, you can poke at it, but otherwise it's not necessarily that useful.
No. So, yeah, we learned a heap from this box. We kind of butchered it a bit because we started doing this in the end of December last year, and I think it's just been too long since doing it and then actually...
Also, we didn't...
Not having enough prep time to redo it before the stream.
That said, we have 2 million imaginary followers and like 3.5 real human being followers. So obviously you guys are willing to put up with us. This is just
used to it by now. Yeah, that's true.
This is all good. Well, there's been a couple that we've thought we've run really smooth. It's just practice. It's been... I think so 10 days since we did the last one, and then there was 10 days before that, before we did the one before that one. So we've been a bit on and off a bit this year. So, but from now we should be back to every Tuesday, 8 p.m.
That's it.
Every week. Now that
we'll be running smoother and smoother.
Now that we're kind of in for the year, Jake and I can like actually sit down and plan stuff a bit more.
I am very, very behind in terms of currently active boxes on Hack the Box. I think I'm like almost 10 behind now, something crazy. So yeah, we've got a lot of work to do, but we'll get around to it eventually. We have done pretty much the foreseeable future in terms of upcoming retired boxes. So we have done YPuffy, which was the most recently released one. We have done Access, which is the soon-to-be retired box. If you have a preference, let us know and we can stream one or the other next week because we are a bit behind. But eventually we'll catch up and we'll start doing the most recently released again.
Also, the video of the last stream is now on YouTube. I will chuck the link in there. Bam! It's in the stream chat. So if you haven't caught that, or I suppose I'll try and stick in some other places, or just go to the YouTube channel and have a look.
Here we go. We'll put it on stream as well.
Yeah, boy.
Yeah, boy.
Please work. Please don't be like, this video is still processing.
This video is not accessible in your region, or whatever it says.
Also, you may notice the start and end music is fairly generic. That's just stuff I do. I even had it was like a fun version of like Katy Perry's E.T., where I just like did like a kind of heavy backing track and then had like a vocal sample of like Katy Perry singing over the top of it. That got flagged for like copyright. It was like, oh, this algorithm's good. So someone else is making money off the videos that we can't even make money off. So I fixed that up pronto. But otherwise, yeah, have a squeeze if you want. We'll probably chuck stuff. That one's a bit late, but so apologies for that. But yeah, we just chuck stuff on YouTube. So we should probably
I think my OBS just crashed.